So the customer, right? Customer, for example, is calling, right? So calling is the customer wanted to pay online. So start. So the website, you go to, you want to pay. It's online banking. So go to the page. So you have a page, right? It's a GUI. So the page start, and then you can interact with the system because you wanted to place the payments. So the system need to know you are the one. You are the one you claim to be. It's calling. You got to make sure. No, the person is calling. So we need to verify that, right? So it's going to enter your ID password. That's so we start the same start. So we have start. It's one server. No, start. Wait for credential. Wait for credential. The same. You got to verify. All right. So home page, and then you enter your ID and password. So we have a server take your ID and password. You cannot do this, but you got to pass, right? So if that is the one to handle that, so back end is a database. So go to the bank, right? Ask to against your ID and password, right? To verify that you are the ones who claim, claim that's you, that's calling, right? Or that's anyone. Yeah. So wait for credential. All right. So a server hosts your ID and password, and then here, this one, right? And this one, it says the login attempt, access granted. So even you see that login, right? Login attempt. So attempt, but couldn't forget. Yes, forget the password. So ID, we enter the wrong password. Can you be verified? You forget your password and you enter the wrong. To be granted or not? Yes or no? No? All right. So here, login attempt. If it's wrong, what do you get? Do you understand this is wrong? Will system tell you? Yeah, will system tell you that's not correct? Shan, if you key in your ID password is wrong, will the system accept? Granted? No. Will the system tell you it's wrong?
Server.
Will tell you?
Yes, server will tell me.
Okay, so if you design that you allow 3 times attempts, right? If you allow that, then what do you get from the system? Will the system tell you that you have 2 more times only?
Could you say that again?
If the designs only allow 3 times attempt, right? So then you fail once. So probably you will get system will tell you that you have 2 times.
Yes.
That, right?
Right.
Yeah. So you have attempt, right?
Yes, I have account.
Yeah. If 3 times you fail, then you cannot access, right?
Yes, it will be blocked.
Yeah. So here you can see that login attempt access granted, now succeed, right? So let's look at this. From this, so succeed, then you can get in, right? As here, logins granted or reject, right? It's granted, that means succeed. It succeeds, then you wanted to pay. So the system then let you in and give you the page, right? So you need to enter your payment. So the payment, okay, if you wanted to pay, then you need to tell the system right? Who will be the recipients, right? Recipients. That if you wanted to pay to a company, then you have the recipients. You will pay to anyone, you have the recipients, right? To someone, you got to pay, right? So creates new payments, and you enter that, right? And Mr. Rice, right here, confirm. Then the server will confirm, right? The server, because server holds your ID password, right? Holds your ID password, and then you enter the information. When you enter your ID passwords against the database of the bank, and then when you enter the recipients, then it's going to ask the third party, right? And verify that. So here, you will get a confirmation. If that's confirmed, get a confirmation. You gotta wait here, wait, and confirm. You confirm, it's okay, right? Then your payment confirm. So everything that happened in only one session, this session does a lot of things. Only one server process that. So this is stateful. Stateful. What's the problem of stateful? So based on my description, so what's the problems of stateful? Happens only in one session, the process by one server. What's the problem of that? It's stateful. So think about that. What's the problem of stateful? Okay, Preacher?
Because the server has to do all these things,
Mm-hmm.
so the server will have a heavy loading.
Mm-hmm.
Yeah, the loading will be more than status,
Mm-hmm.
and the server have to deal with status.
Mm-hmm.
So
Well, if the server or something, goes wrong, what happened?
if it goes wrong,
Yeah.
then the client will not able to do the rest of the things.
Okay. Or what happens that probably it's the power outage, all right? Disconnect, all right? What do you expect the system will do?
What is the power
It's outage,
outage?
outage. It's a break, okay, it's a break, right? Disconnect, right? Something like that. Then what do you expect? The result.
If it disconnected,
And then?
then we are not able to do these steps.
Okay, so here, stateful, because one server takes its over, right? Process everything. What happened if anything, goes wrong, right? Then you break there, right, until it's fixed, all right? If your design is good enough, they can go back to the previous resting, the points, all right? Otherwise, again, you do it again. So you need to, go back to the very beginning, because no helper, no other server can take it. To take it, all right? It's only one server. No other server, can take this. So it is a bad design. So that's why this is traditional. And now we are going to distribute it, dispatch to many servers. All right. So remember that when you wanted to do something online, press an order, you enter your ID, password, all right? So there's one server get it. get it, remember your ID password, right? But only that. Get it? So you probably has experience that. Okay, then check your cell phone or your email. You have a code. Got it? So this code, you got a code and then enter it, right? Then they were taken by another, any available server can take it. So then you got this token. This token is encrypted because it's different from, but actually it's your ID and password. But you got a code. Understand that? You got a code. So you got to enter the code. Could be digits or alphanumeric. You enter the code. The other server take this. All right. The other server need not to know your ID and password, but that is code because it's verified. So test this code to process that. All right. So it's different server. And then you wanted to press purchase to give you a page. You can enter that. It's another server to take it and confirmation. So now here you said first login, second login, or probably fourth login, different server. Handle that. They don't have any communication. Right. So the second server does not need to know your ID password, but got a code. Token. This token then need this token. And the third one need not to know previously. That means they know a little bit. Let's say this. Whenever it break, it doesn't matter. Alright. So break, you already pass 3 session. It's a different session. Alright. You go to the fourth. Whenever it break, alright. And then from the third. The other server can take it. No problem. Alright. So that's the design, the status. So here, tell us that we partition the states into many pieces. Each server takes one piece. So, they would not be affected. One fail, then no other helper, can take it. So yeah, that's the status. So here is the kind of, design. That design, you don't hold everything. Just one. Okay. So and I talk about the connaissance, right? So here you can connaissance. Change one will affect the other, right? So here the same from tightness or strength of the connaissance, right? So you change the name, you reduce the name change of course, but it's a light, it's only name, right? They will not affect a lot. Name or the type, the class change type, right? But type, so they will affect some type. You upcast, downcast, right? The type, you can change that, so it's not a big deal, right? You can easily correct that. Convention, right? So convention, usually when we set a range, right? A range of value, right? It has a meaning. So when you change the range, they might affect. Some value just cannot, you said it's like probably you said maximum that you need to take medication or take some vitamins, right? It is the dose, right? So maximum you can take probably milligram. This is a milligrams or microgram. Milligram, microgram is a maximum for a day at that. So it has a range. It's meaningful. You're not going to change that when you change that will affect. So it's a convention or algorithm, right? You change the algorithm, they will affect other dependent. Algorithm is more complex, right? Algorithm or position, right? Position. You probably you look at your parameter, right? The parameter when you swap the position, they will be different. The effect. So here, that's some stats. You see the one affect the other. We call it static or dynamic. When you run the thing, right? So you're the same. Dynamic. Want to ask you that. So it could be timing, could be value identity. That so you can read that. That's the strengths. Okay. So the way we look at the design, that we wanted to maximize cohesion. Right, maximize cohesion. If it is necessary, we put it lighter, very light, right? Lighter, maximize cohesion, intro, and minimize the communication, across your boundary. So already talk about that. Method signature effect. Right? You know that as overloading, you're not going to have this kind of overloading because you're not going to change the data type return. That's only, not that. So we need to optimize the design. All right. So here, balance understandability with efficiency. All right. So these two concepts, there's a trade-off. Right. If you care more on efficiency, you probably the code is not so understandable, right? Or you care about understandable, right? So it is understandable, or if it's a high understandability, then the performance maybe lower. So it's two. Review access paths. It says review access paths between object, shorten the paths. So that we said it become two level, because two is worse than one, right? So shorten or two is better than three. That's shorten the paths. They will reduce the impacts. Right? Review all attributes of each class. Right? The second one is to review all attributes of each class. If only instance of a single class send attributes to region, updates the attributes, then move the attributes to the calling class. What does it mean? Michelle, what does it mean? Give us an example. The second. Do you understand that? Sammy, do you understand this? Do you understand that? Raise your hand. Do you understand this? Do you understand this, Sammy? You understand that? Give me an example. So I can explain this. Say that difficult. So what about you, you three? Yeah, can you explain this? to answer this? Just so I'm going to invite him to explain that. All right, to explain what you said.
Okay, maybe I can have an example. Maybe today we have a library system, and we have a function is borrow book, and we we can library, yeah, and we have a function is borrow book, yeah, and
The library has a function.
yes, and it's
Borrow book.
yeah, borrow book, and today we borrow book. We maybe is we can get a book and to is我这看那个上面方法是什么？哦 and to get a feature is maybe the book title, but today we can get the title into the book's information, so we can don't to do get title this action. Yes. 我的英文怎么不好we can write a attitude is we can write a attitude for book is book title. So
Now you have a book. So book is a class. So the book is a class.
yes.
Okay, you have a library.
Yeah.
Library is a class.
Library yes, it's a class.
So a library and a book.
Yes.
Right. And then the
And-
library.
And today we can maybe is book is in inheritance to library.
So book is a kind of library.
A puzzle. Sorry.
Okay.
So today we the book has attitude is book title.
Execute the book title.
Yes.
So book has attributes title.
Yes.
And
And-
get title, set title like that.
Yes.
And then
And so we can today maybe we do the function is borrow book, and we can
Borrow book.
don't to do get title. We can certainly get title from the book because it have attitude title.
so borrow book is a function, right?
Yes.
Then this function belong to
This function belong to library.
library.
Yes.
That belong to library. Okay. And the library has a lot of function, right?
Yes.
Like borrow book, return book,
Yes.
browse,
Yes.
a lot of things, right?
Yeah, a lot of things.
So we just talk about coherent. It's not coherent at all.
Oh,
It does a lot of things, right?
right.
So library like a system.
Uh-huh. What? Can you say it again?
A library like a system because it has all the functions.
Yeah.
It's
like
not a good
system.
design, right?
Yes.
Yes.
Oh,
So
Oh. Okay. Maybe.
okay, Tim, would you explain that? Yeah. We cannot finish this chapter today. So next we will continue.
So I think soon we have two class, maybe class A and class B. And in the class A we have an attribute, and class B need to maybe update the class A's attribute, and only the class B will do that. So we can put the class A's attribute, move to the class B to improve the performance like that.
So do you understand that? We have two classes, A and B, right? if B depends on A, B depends on A, okay. So which one propose a request? Visual, which one propose a request? Which one ask for help?
So
Which
So-
one ask for help? Propose a request.
I think it is B.
B propose. So B asks something from A.
Yes.
All right. So Tim says B asks something from A.
Mm.
So we take the measure, into B.
Yes.
Okay. So into B. What about the cohesion? It says lower the cohesion, raise the cohesion, strengthen the cohesion, or weaken the cohesion.
It will raise the cohesion.
Improve the cohesion.
Yes, it will improve the cohesion.
Improve the cohesion.
But isn't it to move A's attribute to B and make it perform well? Isn't it? It isn't what Tim just said.
So it says raise cohesion, right?
Yes.
And you said it's hard to. Maybe not. Lower the coupling and cohesion, you're not be sure. So what do you think about this? Right. Yeah, raise a lot of issue. So I wanted to answer this. I propose a request. Alright, I am the B. I propose request to Ian. Alright, because I know Ian can, can do that. Right, Ian can do it. So I ask Ian to give me the information. Right. So that means, if our design does, Ian is a class. Ian is the attribute and method. So every time it says, if the situation is that here, Ian has the thing, Ian can conduct the thing, only I need, but no, probably nobody will need it. He hosts the thing, I know that. So always I ask Ian to give me that. So what about a good design? The good design is we move, all right, that part to me, because that would be better, I ask myself, right, to reduce coupling, but also reduce cohesion. Because those parts not supposed to be, to belong to me, all right. So this is what I said, that even it's a scale, right, but not always. Sometimes we can raise, improve cohesion also, So, but here, this one, or when we raise one end, make the coupling tighter, that's not good, right? But sometimes, it's the other way, it's not lower. And here, lower the coupling, but also reduce the cohesion, because I got extra thing, all right? But you probably will do this design because nobody needs that. So it holds that even, make it coherent, right? Because of coherence. But nobody needs that. Only me. No, I need that. So we need to refactor it, take that apart from Ian and move it to me. But you look at the matter, it's not coherent. But your design, it happens that I need the thing. B need that. So the team got stuck because it says usually it's a lower cohesion, lower coupling, they will raise cohesion, right? But not always, right? Here we lower coupling, but the other hand lower cohesion. You got it, right? So yeah, it says it's not sure because usually we think that if we improve coupling, that means reduce coupling, right? Reduce coupling. We hope that reduced coupling is a good design. On the other way, right, reduce coupling, we hope that can improve cohesion. But this situation, no, right? But we prefer to take this because that's the only situation I ask. So B always asks this word. So we make it less coherent, but it is a good design. You got it? Hope you can follow. So here, it says, if only instance of a single class sends message to read. This is the only one as this part. Before there's no others. So you can do that. But if not, if here, if it's more than one, and need this part, you're not going to do that, right? Because when we take it out, then they are going to ask this and ask, or they are going to ask B, right? But that become one of that is either it's a less coherence, and your change will affect the others. Well, no, we got to change the target, which we rely on this, but it doesn't make sense, to move the operation to B. You follow? Yeah. Okay. And it says consider execution order of statements in often used method. Search in a predefined order. What does it mean? It should preview, right? So yeah, often used method is search in a predefined order. Answer. Yeah, otherwise answer, or otherwise I ask Tia to help. Explain that. You guys. Explain it.
I have some thoughts, like if you have a function, and the function will have a like check, like I'm logging, and if I log in 3 times with the error password, it will be blocked. So in this case, in the function, we should check if I am blocked first. If I'm blocked, I don't need to do the next thing in the function. I just return and false like this. So if I'm not blocked, and I will do the next and check the error or the thing, it will can be return false. Do the first, and it will make the function more quickly and reduce the unnecessary calculation.
So facing with that logical, correct that you attempt. If it fail, then do something succeeds, right?
Yes.
And it's in a order, right?
Yes, in order.
So do we need to pack it? Pack. Do we need to pack all this? Packets.
What
Packets. For
What is
example,
packet?
here to verify,
Yeah.
or and then so what you just describe with packets, it's all belong to this function, or not?
I think maybe should.
Okay, so here, do we define the order that you cannot change that?
Define the order, cannot change.
We define the order, got to follow that. Set the order, and we hope that everyone just perform this, verify, then follow that. You cannot change.
I think it can be changed.
Can be changed.
It can be changed.
If it can be changed, then you cannot pack it. You want it to pack it or not?
Not.
If you do not want to pack it, then can be changed. Then there's a no predefined order, right? You can change that. So here it says a predefined order, right? So it could be more complex than that. So suppose that we have, if we want to complete a function, then need to process a couple method as this, and then we ask this, but here we got this result is not enough because this result is going to process, right? So so I process that probably, and I need others, and then process it. So every time, here, I ask some piece of that, and then conduct the processing and get a result. If everyone do that, still the same. So it says, well, in this situation, we predefine it. So here, predefine it. Everyone just follow it, right? Otherwise, you need to set, okay, I take this, I take this. So we packets, usually packets, predefined order. So anyone just do it. So let's just ask, well, Eric. So like the simple ones, like procedure code, right? Procedure, you probably know, but a procedure usually that happen within a class, but it could be more complex than that. We jump out, we're going to ask some components. We will combine different components, even more complex, and then finish the task. So since it has the order, and it is very efficient way, if we predefine that, right? We just follow follow that. So here, if that happens, it's optimize the design. All right. And everyone need to get the same results. I need to add different components, and then we pack it. So here, often used search in a predefined order. All right. So last time when we talk about, we wanted to reduce many to many, right? So many to many, a lot of crime. They ask for processing something, but not from one source, probably different sources. So we have a lot of requests, a lot of crime. They are going to ask, process something, right? So how do we deal with this? From many to many, we add one, right? This one. So whenever you add something, and this one, you will take it because you know the predefined order. It's a facade, predefined order, and process that and give you results. So here, it's often used method. We know that if we wanted to get something result, but should process that we wanted to pass, right? Pass it, and the seconds, the other, we're going to do enricher, and the third would do some. But for each of the process, we separate it. So someone only need to pass, then that is enough. But someone need to do more. They need to combine to process the first and second and get a result. If someone needs do more, they need to process that. So we have a helper. This helper, you know that when a request needs only pass, I give the pass to him. I need something more, enricher. I need to pass enricher, so I keep that. So here, it's often used method searching the predefined order. Or derived attribute. We know derived attributes, so we don't need to compute that. The last one, consider combined classes that form a one-to-one association. What does it mean? Chen?
It means like if I have a I have a car, and I have a car detail class is a different class, and a car have a car detail classes, and the car detail classes have more attributes to define the car, and is a one-to-one association, and you can put the car detail to the car classes.
Okay, so this similar to this, the second one. Is that what you said?
Kind of.
If it's a kind of, then how come it's going to separate them? So you combine that by combining into one, right? Like what I just said. That. You said that. So, kind of, but it is different, right? It's part of that, but now you said that. So what it says is like this, right? So it's a car detail, right? So move that become A. take out this part,
Yes.
right?
Right.
This is a little bit different from this, right? Just
A little
piece of
different.
X, right? Piece of X
It's
to,
piece of-
to B, right? And here, we should say that this or that. Is this a car? Car detail. Is this a car? Car detail. Is a car? So it's a car, right?
Yes, it's a car.
Car has car detail,
Yes, car detail.
and you move everything. So here, car depends on car detail.
Car detail.
Car detail
Aggregation
depends on
to-
car. Car detail depends on car.
No.
So car depends on car detail.
Maybe not.
Maybe not. But you said this, right? Car. Car has car detail.
Is a
Car depends on car detail.
yes. It depends on car detail because car need
Detail.
at least one car detail.
So now you don't want. So which one you wanted to?
The car detail go to the car.
Okay. So car said I don't want it to look upon car detail. So I wanted to combine it. So take out this. It said take out this.
Yes.
To become
Only
the
car.
whole. This
Yes,
whole.
the-
This whole expands. No. The whole has this, and then we wanted to take this out. Become A. Right. And the reason for that because it's a part of that. Then well, I take it out. Become A. The reason because it's aggregation, so we use this. We gotta have a reason, to have the part out, and now you want it to take it back. Is this should we have reason, to separate them, aggregation? All right. If we separate them, right, because it's meaningful. That's meaningful because it's going to be used by others. And this could be very important, so we take it out. So we have a whole part. All right. And here, it's just reasonable to think about one-to-one. So what is one-to-one association?
How about like
One. Here it says one, right? But it says one-to-one.
one-to-one? Maybe it's like I have ordered something. I'm a market and I order something like I ordered a 100 bottle of water and 100 bottle of water maybe will sell to 100 customer.
Customer and item, so I need to order, right? So,
Yeah.
so here you mentioned different thing, right? You have customer. You need to press order, so you need to have an order. And you have item. not only talk about the one thing, all right? So customer, when it's press order, probably it says 100 bottle of water. That's the item, all right? Now what? Well, that's interesting. No, this chapter we cannot finish that because we'll continue this, and probably to go to chapter 9, right? So what I'm concerned is about your understanding of that. So think about that. Every situation is quite flexible, but you need to know why, and is this a good design? And what about the principle related to this? Okay, and then we can pause here. Think about a one-to-one, and next week, right? I'll keep you more thinking. That we'll talk about the OCL, right? So preview it, all right? It is supposed to finish today, but it's parenthood. No, all right. So next week we'll continue that. So think about all this. I will use different example to ask you, make sure you understand. Okay, see you next week.